Hello and welcome to the section 5.3 video. Today we're talking about applying percent problems, and so the main idea is going to be that we're going to look at some different markups and markdowns and probably be combining a lot of what they do, and we really have some multi-step problems coming. So I do like these. I think these are sort of great tools that you can use in a variety of situations. The first section is about finding total cost. It says that sales tax is a tax on the sale of an item or a service, is a percent of the purchase price that is collected by the seller. Now, we in Oregon are lucky enough not to have a sales tax. There's good and bad about it. Obviously, the good part about it is the price that we see is the price that we pay. Whereas if you go to other states, or if you've been in other states, you'll notice that you're going to pay a certain price for something, but when you go to check out, when you go to leave, it's not going to be that same price. There's a built-in tax that then gets applied to that. And then the reason for that is that tax money goes to other things that help out. So yes, we don't have a sales tax, but that definitely means that we're missing out on some help on certain things. So in this first example, it says that Marcus buys a varsity jacket from a clothing store in Arlington. The price of the jacket is $80, and the sales tax is 8%. And what's the total cost of the jacket? So they're going to use a bar model to find the amount of tax. So we know that it's 8%, but we want to know what 8% is of that $80. Okay. So the total cost is going to be the original $80 plus the 8% of that $80. And they say because they go way deep into this, the easy route here is to take 8%, and we would say 0.08 times the $80. And we're having pen issues again. That's great. I can see how fun this is going to be. So the taxed amount, they go at it a little bit different way. They say that because 8% is 4/5 of 10%, the tax is 4/5 of one part of the whole bar. Since the one part of the bar, 1/10 of the price was $8, we have to find 4/5 of $8. You would find the same thing if you would take the 0.08 and multiply it by the 80. Okay, you'd get $6.40. So the entire price of the jacket is the jacket price, $80 plus the $6.40. So instead of, whereas we in Oregon would go and just pay $80 for that jacket, the Marcus in this example has to pay $86. So kind of an easier way to think of it, because we do something similar to this when we go and we eat at like a restaurant, we'll leave a tip. It's like a tip on everything that you buy. Okay. Sharon wants to buy a shirt that costs $20 and the sales tax is 5%. How much is the sales tax in dollars? And then what is the total cost of her shirt? So again, the easy way is to think of 5% times the $20. And I should have had this set up. Let me get a calculator set up here. So now I've got us a calculator set up, and I'm just going to look at 5% times $20 is $1. So that percentage is $1. So kind of our first answer being $1. And the total cost is going to be the $20 of the original plus the 5%, which is $1. So it's going to cost her $21 to buy the shirt. Okay. Finding simple interest. This is another occasion where we use percentages. So it's finding simple interest. When you deposit money into a savings account, your money usually earns interest. So the idea, sort of the long and short of this idea, you're giving your bank that money to use elsewhere. So believe it or not, typically your money's in the bank somewhere. But if you have enough of it in there, there may be portions of it that gets loaned out. But they still have sort of an electronic record of your money, to where you can get that when you need it. But believe it or not, the actual money that you put into the bank doesn't stay in the bank, okay, or doesn't stay in a little lockbox that's just your account. So because you're allowing the bank to use that money when it's in a savings account, excuse me, you're earning interest on that. Okay. The other situation is that when you borrow money, you have to pay back the original amount plus some interest. So both of these are examples of simple interest. So simple interest is a fixed percent of the principal, the original amount of money that you either put in or borrowed from the bank. So it says here that Terry deposits $200 into a bank account that earns 3% simple interest per year. So every year that $200 is in the account, you're going to increase the amount in your account by 3%. So they're giving you money just for storing your money there. It's kind of cool. And we want to find the total amount in the account, assuming that Terry doesn't use any of that money after 2 years. Okay. So we want to find the interest earned in 1 year, then calculate the amount of interest for 2 years. So we write 3% as a decimal, 0.03, and we take interest rate times initial deposit. And so after 1 year, your money has earned $6, so it's increased in value by $6. Okay. And I guess that's how it works. There might be something weird going on there. But if you find that it earns $6 a year, see, I don't know if I believe in this or not. It may be the case that it's this way. I'll talk about what I mean in just a second. So you earn $6. Terry earned $6 a year on his $200 that he deposited. Okay, so after 2 years, he has $212. $6 times 2 is $12, and add that to the initial deposit. Now, my concern here is it may be, and this would increase this problem's difficulty just a little bit. It may be that at the end of the first year, he has $206. And then I don't know if that $6 that he previously earns interest itself. Because if it did, you would want to multiply that by the percentage, and you would get instead of earning $6 that second year, you'd earn $6.18. So it could be that at the end of 2 years, you'd have $212.18, but I'm not positive on that. I know that's the 3% interest that you would earn on that $206, but the bank may do it to where they don't allow you to earn interest on money on interest dollars, basically, on the money that they gave you. So just something to think about and something to be sure of when you get a bank account and do things like that. So regardless, we're talking about a difference of of 18 cents, so it's not that big of a deal. Write an expression you can use to find the total amount in Terry's account. Okay, what are we thinking here? So we took the initial deposit times the interest rate. So I'm probably going to write these out in words, as much as that's painful. So initial deposit times interest. And then we took that amount and multiplied it by 2, or the number of years. And so we would do all that, and then we would add our initial deposit. So that's just kind of a recap of everything we did. Now, why did I do that? Because I could, if I had another problem that was similar, I could do that same thing again and just use my expression here to figure out how much was in his account. The next one says, Ariane borrows $400 on a 4-year loan. She is charged 5% simple interest. So that's probably, simple interest, I think, is the specific one that doesn't add interest to the amount that's been added to your account. Okay, so that's the simple interest idea. So borrows $400 on a 4-year loan. She is charged 5% simple interest per year. How much interest will she be charged for 4 years? And what is the total amount that she has to pay back? So this always shocks a lot of even the high school students that I deal with, that when you take out a loan, most of the time you're going to pay back more than what you took out. It's just over a longer period of time, and you're taking out this loan because you're saying, I need $400 right now, and I don't have $400 right now. So I need to take a loan out to get that amount, and I'll pay you back in smaller chunks over 4 years. So anyways, we would do the same thing. It's just instead of a deposit, we have a loan amount. We would consider this to actually be that principal value. So we're going to take 400 times the interest, 0.05, times the number of years, 4, plus the original amount. So let's do some calculations. 400 times 5% times 4. So in interest, they're charging us $80. And with the initial amount of 400, we would be paying back $480. So how much interest? That is $80. And how much are we paying back total? $480. So just needing that $400 right now ended up in the long run over 4 years costing us $80 because we didn't have that 400 that we needed. All right, now for some problems that use some multiple percents. Okay, some situations require applying more than 1% to a problem. For example, when you dine at a restaurant, you might pay tax on a meal, and you tip the wait staff. So you tip the people that helped you out. The tip is usually paid on the amount before tax, and when you pay on a sale item, you pay only the discounted price. So we've got a couple of different styles of examples. Okay, so the Maxwell family went out to dinner, and the price of the meal is $60. The sales tax is 7%, and they also want to leave a tip of 15%. So the big thing is when you are figuring out your tip, you do that from the original amount, the $60. Okay, So they say that the bill for the meal is $60, the sales tax is 0.07, and the tip is 0.15. The total cost will be the sum of the bill, the sales tax, and the tip. So again, we figure all those out separately. You don't have to, so the sale or the tip you figure out before you apply the sales tax, and you're not taxed on the tip. Okay, so we need to find the 7% and the 15% of the $60. So the sales tax gives $4.20. The tip is going to be $9. So the total cost is going to be the meal plus the sales tax plus the tip. Okay. Then I want to, for this one, what did they say on that? When you pay tax on a sale item, you pay tax only on the, okay, only on the discounted price. So on this one, that's where that statement comes into play. It says Samuel orders 4 DVDs from an online music store. Each DVD costs $9.99. He has a discount code for 20%, and the sales tax is 6.75%. So the big thing there is that we're going to pay sales tax on the discounted price. So we need to figure out that discounted price. Since we're getting 4 DVDs, we want to start off by taking our number of DVDs times the price of a DVD. So let's just figure out what that is. So our total bill here is going to be $39.96. And then we've got to take the discount into play. So we'll discount that by 20%. And maybe to make this a little bit quicker and easier, or just look at another way to do this, if Samuel gets 20% off, that means he's paying 80%, right? If I take 100 minus 20, it tells me that he's paying 80%. So we can figure out this in the one-step method by multiplying this by 0.8, which is 80%. So we can times this by 0.8. And so overall, we'll go ahead and round that up at this point. After the discount, he's paying $31.97. And then we have a 6.75% sales tax. Take the decimal, move it 2 places to the left, and that's what we get. So let's rewrite this because we did round it. You would get a little bit different answer if you didn't round it, but not by much. And so the sales tax is $2 and let's say 16 cents. So that's the tax. That's the price after discount. And so our total payment is going to be the price after the discount plus the sales tax. So we have 31.97 plus the $2.16. And there we go. The total cost is going to be $34.13. And you can put that here. Okay. And that'll be it for today. I think the biggest new idea today for a code word is going to be tax. All right, so our code word for today will be tax. I hope that helps figure some things out. Make sure you get the reflection done. Have a great day, and we'll see you in class.